Say done. Okay, then it's fine. So now what I'm going to do, it is to share my screen. But before I do that, let me just make sure that I'm in the right folder. And today's grade 10 physical sciences. And as we discussed on our previous lesson, we said we are going to do some exam question papers. I've got one that we're going to be looking at in today's lesson. And let's see. This question. I'm just curious to know what happened on this question, but it's fine. It's fine, it's fine, it's fine. Let me continue to share my screen and then we will discuss once I do this. Okay, guys, I will need you to just have a look at this and confirm for me if we have done this before. Can someone just confirm for me if we have done this question 6.4? We haven't done this question, isn't it? It just feels like we have gone through this question, unless if we just browsed and not do the calculations. Guys, we've never done this question, isn't it? I don't think so. Okay. So, guys, this is what we're going to do. Based on what we did on our previous lesson, I will therefore give you some time to work on these questions. Let me first find out something. So I've got that question, I've got that question, I've got that question. I'm just trying to think if you will give the answers in the comment section or if you will send them to me via a WhatsApp inbox. No, not WhatsApp, via WhatsApp inbox, but I'll give you some time to work on it and then I will just choose whoever to explain how they've worked it out. So let me just indicate to say this first question where they want you to calculate the total resistance of the circuit is given 5 marks. I will give you 3 plus that, okay. At 1915, you should be done with this question. So you can start working on that one, and then as soon as you are done, you just comment in the comment section and say you are done. I will just choose whether you are done or not. I will just randomly choose, and then you explain what you have done or how you've worked it out. If you're still working on it, you just take us through what you've done, and then you take it from there. Guys, did you hear me on that one?
Yes, sir.
Andrew Katlego Mangulesos Tabile. Did you guys hear me?
Yes, sir.
Okay, 100%, then it's fine. Let me mute myself. Guys, so a good question there. It's only the first question that you do. Only the first question. Then once you're done with the first question, we will move on to the next. But once you're done with the first question, in the comment section, you can just make me aware to say I'm done. And then, yes. Guys, are you still working on it? Andrew, are you still working on it?
Yes, I'm almost done, sir.
Okay, Katleho, what about you? Mangleso, Stabile, are you still working on
Almost
it?
done, sir.
Okay, then it's fine. I'll add an extra Okay, let's see. Andrew, what did you get as your answer?
I got 18 ohms.
You say 18, comma?
18.
09. Okay. Katleho, what did you get?
So I got 3.
We have 18,09 ohms. Katleho got 3 ohms. Mangaliso, what did you get?
So I got 12.
We also have an answer of 12. Okay. Let's see who's the other. Lena. Okay, Stabile. Stabile, what did you get? Stabile, what did you get? Chief Stabile can hear me. Let's see. So I got 51 ohms. Okay, Stabile got 51 ohms. Yo, all of you guys got different answers. So that means if there's someone who's correct, it's only one and the rest is wrong. Okay, then it's fine. Okay, on the side, I'm just going to try and do it. Then we will just know what the final answer is supposed to be. But let's see, we have 12, 36, and then 3. Okay, let's see what the final answer should be. So you will have to work out the one for the parallel, which is 36, and then 12. The 6 and 12. The answer for that question is supposed to be 12. So that means everyone who did not get 12, you will need to redo it, but not now. But just be aware that the answer for that one is 12. Any other answer is wrong. Refer to the notes that we did on our previous lesson regarding how we calculate R total, especially when you have a combination of a parallel and a series. So now I want to the next question where they say calculate the quantity of charge through the 3 ohm resistor in 2 minutes. So what I can tell you is that you need to go to the formula sheet and look for the formula that we can use in order to calculate charge. How many formulas do we have? We have multiple formulas there. You will therefore need to select the formula that can assist you to calculate charge. So let's say we have formula number 1, formula number 2, formula number 3, formula number 4. Which formula do you guys think is the relevant one to you?
Formula number 1.
Formula number 1, yes. So that means you will use formula number 1, which says charge is equals to current times time. Let's go back to the question itself. I will just write it down there to say the formula for charge, it's equals to current multiplied by change in time. I think this is enough for you to get started. So for this question, okay, it's fine. We can say at 19, let's say 35, you should be done. If you finish before that time, in the comment section, just comment and say done, so that I'm aware that you are done. If all of you are done before that time, then we can continue. Guys, Andrew, Katleho, Mangliso, and Sitabile, do you know what you're supposed to do?
Yes, sir.
Yes, sir.
Okay, then it's fine. You can start working on it. Okay, we have Katleho who's done 360 coulombs. Okay, and let's see. Andrew, what about you? 360 V. Okay, that's good. I think you guys can just comment in the comment section. I also got 360, and that is Table. Who else needs to comment? Katleho, I think it's Katleho who hasn't commented. Katleho, what about on your side? Katleho got 360. Okay, that's Tabile. That means it's Mangaliso. Yes, Mangaliso. What answer did you get? 360. Let's see what you guys have done. Let's see what you guys have done. Okay, so what we know is that the current, what? This pen fell, okay. So the current passing through the 3 ohm resistor is that one of 2 amperes. And then in terms of the time, it's given in minutes. So in physics, we don't measure time in minutes, but we measure it in seconds. So we need to say 2, then we multiply it by 60, so that we convert it from minutes to seconds. So it's like we have 2 times 60, which is 120. So it's like we have 2 times 120. Is it not 240? 240 what? 240 coulombs. Yes. But why? How did you guys get 360? Or did you maybe say 3 multiplied by 2 times? Guys, how did you get 360? Did you say 3 times that?
Yes,
How did you guys get 360?
3 times
I say 3
120.
times 120, sir.
Oh, but do you notice your mistake? Because the
Yes,
formula
sir.
say I, and I is the current in ampere, not it's the formula is not U is equals to R times change in T. So you must always check to say on the formula, that means whatever that I substitute for A, it must be something measured in A. And then for T, it must be measured something measured in seconds. So that 3, that they're just saying they want the quantity of charge that flows through. The key word is that flows through. It's like they are saying something that passes through window number 7, but it has got nothing to do with that window number 7. We just want to know whatever passing through that. So just be careful of such members to know that even though they mentioned that, but you just need to know what is the current passing through there. You remember we're talking about the splitted and unsplitted current to say that one that is passing through there is the unsplitted. Then it splits, it splits, it splits, it splits, and then from there it joins. So can you see the current that is passing through series? It is the unsplitted current. And then the one that passes through a parallel connection, it splits. The other one that side, the other one that side. Guys, does it make sense what I'm explaining regarding the flow of current? Do you all understand what I'm saying?
Yes, sir.
Yes, sir.
Yes, okay, 100%. So now let's move on to the next question. And the next question, that is 240. Okay. The next question, they are talking about how much electrical work is done by a 3 ohm resistor. And they are saying in 2 minutes. I'll just write that answer there. You say the answer that we got there, it is 240 coulomb. They're still talking about the same a resistor of 3 ohms, but in this case, they want you to calculate the electrical work. So on this question, I will give you what am I going to give you? Okay, it's fine. I will give you you won't need a lot of time on this one. Okay, it's fine, it's fine, it's fine, it's fine. Let's say 1950. But let me go to the formula sheet and then I won't explain to you. Just take a screenshot of this, then you will figure out which formula will be relevant to use. You will figure out which formula is the relevant one to use. Did you guys take a screenshot?
Yes, sir.
Okay, then it's fine. I'll go back to the question. Then, based on the formulas that you have, you will check which one has that letter that they want you to calculate, and then you check if you have everything on that formula. If you don't have it, you calculate it.
And sir, and they're saying how
Is it a
much
question?
electric? Yes, sir.
Yes. What is the question, Andrew?
And they said calculate how much electric work. Are they saying you must calculate the electric current? Or already see.
No, it's work. It's work. So current, they will say current, or they will say the reading on the ammeter. So the electric work is work. So if you took a screenshot, the symbol for work is W. Did I answer you, Andrews?
Yes, Miller.
Okay. Okay, let's see. Andrew, Katleho, Mangliso, and Stabile, you guys can comment in the comment section, or you can just let me know what answers are you guys getting. Katleho, what answer did you get? Mangliso, what answer did you get?
So I'm not sure about
5760.
mine.
What did you get?
I got 1,440 joules.
1,440 joules. Okay, another one. What did you get? I saw someone, I think they commented something. Remember, it must go with the unit. I just saw a number there, 5760. It must go with a unit, 5760, I think. Work and energy are measured in joules. Let's see. Another one. What answer did you get? Andrew and Stabile, what answers did you guys get? Two joules. Okay, Andrew got 2 joules. 2 joules. Okay, another one. This is Andrew. Stabile got 0.25 joules. Okay, we also have 0.25 joules. Okay, so this is how you would then have to work it out. We go to the formula sheet and then we check, okay, it looks like this is the formula that has work. Remember, these formulas are for electric circuits. So questions on electric circuits, you will be using those 4 formulas. You just choose the relevant one. So it looks like that one which says V is equal to WQ. So that means V is equals to W over Q. V is equals to W over Q. So that means W will be equals to, you just cross multiply, it will be V times Q. So you need to make something the subject of the formula. So it looks like we do not have V, but we do have Q. We calculated it to be 440 coulombs. So that means V is missing. So we need to calculate V. V where? V on the 3 ohm resistor, because it is the work on the 3 ohm resistor that we are looking for. You will therefore say V equals IR. What is the current passing through the 3 ohm resistor? We know it is 2. And then R, it is obviously 3. So this times that is 6 volts. Then it means you are therefore going to substitute 6 volts there. Then you calculate your work, which is going to be in joules. So remember, this calculation and that one, it is for the same question. So you might find that you will get a mark for writing the correct formula. You will get a mark maybe for that, and you get a mark for final answer. That's how you get that 3 marks. So let's check what the answer should be. 6 times 240, 1,400. Yes. You see, for 1,440 joules. That's how you would work it out. So sometimes in physics, you know you have to use this formula, but there's something missing on this formula. Then you must go back to the formula sheet and look for another formula that can help you to find that. And then you find it. After you find it, then you substitute it on the actual formula. Did you guys understand? Did it make sense to everyone?
Yes, sir.
Guys, did you all understand?
Yes, sir.
Guys. Wait, Mangoli, so did you say you understood? Did you all understand?
Yes, sir.
100%. So now, on that last question where they say, what is the reading on V2? I will give it to you guys to quickly work it out. I did notice something, honorable members. Can you guys see? We were given the reading on V1. Can you guys see? That reading there on V1, it was given to us as 6 volts. So we did not even have to calculate it there. We just had to take it from there and substitute it there. So that's a bonus for you to say, if it was not given, that means we would have to calculate it. So it does now make sense why it's 3 marks. It's 3 marks for the correct formula, 3 marks for correct substitution, a mark, and then a mark for correct final answer with the correct unit. So you see now, when they say the reading on V2, it's what I was explaining to say, it just has to be total minus that one. Then the remainder is the electricity that goes there. That's why even in the question, they don't say calculate. They say what is. They know it's something that you must just look at and know what the answer is supposed to be, which is 24 minus 6. Is it 18 volts? That's how you would work it out. So those last two questions, do not worry much about those. We will look into those when we go deeper into this topic. So guys, we will end it here in today's lesson. I hope you guys did enjoy and learn a few things. Any more questions, or are we done, honorable members?
No questions.
No questions, sir.
No questions. I think we are all okay. Okay, and it's fine. I'm quickly jumping onto the next lesson. But for now, we'll just leave it